Hello friends, today's question. In a collinear collision, a particle with an initial speed v0 strikes a stationary particle of the same mass. If the final total kinetic energy is 50% greater than the original kinetic energy, the magnitude of relative velocity between the two particles after the collision. So in this case, we are given two particles and both have same mass. So let us suppose we see a particle 1 having mass m moving with the velocity v0. This is particle 2 having same mass but its velocity is 0, and after collision they will be moving rather in the same direction. Let us suppose this is particle 1, this is particle 2. So particle 1 is moving with the velocity of v1 after collision, and particle 2 is moving with the velocity v2 after collision. This is particle 2. So particle 1 is having velocity equal to 0. So this is before collision, and this is after collision. So we can use conservation of momentum. We can say by conservation of momentum, momentum before collision, that is m v0 plus m multiplied by 0 will be equal to m v1 plus m v2. So here this becomes 0, m cancels out throughout, so we get v0 is equal to v1 plus v2. Let us call this question number 1. And in the question it is given that the final total kinetic energy, so we can say kinetic energy final is 50% greater than the original kinetic energy. You can say kinetic energy initial plus 50% of kinetic energy initial. Therefore, we can write this as kinetic energy final will be equal to, this will be coming as 1.5 kinetic energy initial. Initial means before collision and final means after collision. Now we substitute the values, or rather we can say formula. So kinetic energy final will be kinetic energy of particle 1 plus kinetic energy of particle 2. So we are going to get this half m v1 square plus half m v2 square is equal to 1.5, and kinetic energy, only one particle is moving with velocity v2, particle 2 is stationary with velocity 0, so we get this is half m v0 square. So this half cancels throughout as well as m goes away. So from here we can say that our v0 square is equal to v1 square plus v2 square. This is equation number 2. Now we are supposed to find out the relative velocity between the two particles after the collision. So relative velocity between two particles after collision, and this can be written as v1 minus v2. Now we can arrange this v1 minus v2 according to the given equations. So we can say our v1 minus v2 can be written as v1 plus v2 whole square minus 4 v1 v2 and its square root. And let us call this as equation number 3, and we already know, or let us solve this part first. v1 plus v2 whole square, this will be written as v1 square plus v2 square plus twice v1 v2. But we already know that v1 plus v2 is equal to v0. Okay, so here we are going to use equation 1 and 2. Using equation 1 and 2, we get v1 plus v2 is v0, so this will be v0 square, and v1 square plus v2 square is equal to 1.5 v0 square plus twice v1 v2. So here we can find out value of twice v1 v2. Twice v1 v2 will be equal to 1 minus 1.5 v0 square, or we can say twice v1 v2 will be equal to minus 0.5 v0 square. Now we are going to use this in equation 3. So let us call this as equation number 4. Using equation 4 and equation v1 plus v2 1 in equation 3, we get v1 minus v2, and v1 plus v2 is v0, so this is v0 square minus, and 4 v1 v2 can be written as 4 v1 v2 can be written 2 into v1 v2, sorry, here it is 2. This will be coming as twice minus 0.5 v0 square and its square root. v0 we can take as common, so this will be coming as v0, and inside it is left for us 1 plus 1. So we get v1 minus v2 is equal to v0 square root 2 meter per second. So this is the relative velocity between the particle 1 and particle 2 after collision. This is the relative velocity between particle 1 and particle 2 after collision. And we have option C is the correct option. So here we can say that option C is correct. So this completes the question. Thank you.